Okay, so on this problem, I've got a steel shaft, diameter 50, fixed at both ends, pulled on with a torque, and I want to find the maximum shear stress um, in the shaft region. So we start with doing free body diagram. Okay, so you've got that 300 Newton meter in the middle. That means on A and B, you have, um, I'll call this A, I'll call this one B, acting against that. So statics tells us that A plus B has to equal that 300. Okay, so that's the statics equation, but I need another equation because there's two unknowns in that, and that's where I'm going to use the angle of twist equation, where the angle of twist, the compatibility equation, the total twist has to be 0 between A and B because, again, they're fixed. So basically from A to C is going to twist some amount, and then C back to B is going to twist another amount. So essentially what I have is, you know, let me just write it. I've got basically the twist through A, so we'll just call it AL over JG, okay, minus BL over JG equals 0, because one twist one way, one twist the other way. Adding them up, the total switch has to be 0. So now I'm going to go through and plug in things that I have. Of course, I'm going to realize that it's the same radius of the shaft, so J is not going to change, and it's the same material, so G will not change at all. So it's really just AL equals BL, where L is 0.4 A and L for B is 0.8 B. So now I've got two equations. There's my statics equation. Here's my compatibility equation. From that, I can calculate A and B, where A becomes 200 and B becomes 100. Okay, now knowing that those torques are those, I can go ahead and find the shear stress. So the shear stress in A is going to be that 200. Okay, this is going to be TC over J, where C is the radius, so 0.025. And then I've got the polar moment of inertia, which is pi over 2 times 0.025 to the fourth. And from that, I get the shear stress in A is 8.15 megapascals. Do the same thing for B, which again is going to be TC over J, where T is 100. C and J are going to be the exact same thing as they were before because it's still 25 millimeter radius for the shaft. The maximum shear stress will occur on the outer edge, so C is going to be 0.025, and again that's going to be 4.07. So we did this with axial loading, but same idea. You start with statics. If you don't have enough equations, you use a compatibility equation using the angle of twist and what we know about it to calculate those things.